Hello, my dear students. A very warm welcome to all of you in Shri Jayendra Rank Zone. I am your friend and mentor for the subject Business Economics. In this lecture, we'll continue with Chapter 3, that is Theory of Production and Cost, and in particular, we'll continue with Unit 1, that is Theory of Production. All the concepts will be covered in the coming series of lectures. So, let us continue. This is lecture number 6. We are starting with returns to scale. Returns to scale, or we can also say that the law of returns to scale. It is also known as the law of returns to scale. We shall now study about the changes in output when all factors of production in particular production function are increased together. That means what? Fixed factor as well as variable factor, both the factors are increased together. Increased together. In other words, we shall study the behavior of output in response to change in the scale. A change in the scale means that all the factors of production are either increased or decreased in the same proportion. Change in scale is different from the changes factor proportion. So, changes in the output as a result of variation in factor proportion, land and labor, as seen before from the subject matter of law of variable proportions. On the other hand, we can say that the study of changes in the output as a consequences of changes in scale forms the subject matter of returns to scale, which is discussed below. It should be kept in mind that the returns to scale faced by the firm is solely technologically determined and not influenced by economic decisions taken by the firm or by market conditions. Returns to scale may be constant, increasing or decreasing. So there are three stages: increasing return stage 1, constant return stage 2, decreasing return stage 3. If we increase all the factors, fixed factor and variable factor, labor and capital, the scale in the given proportion and output increases in the same proportion, returns to scale are said to be constant. Thus, if doubling or trebling of all the factors causes a doubling or trebling the output, then returns to scale is constant. But in some cases, if the increase in all the factors leads to more proportional increase in the outputs, in that case we can say that the returns to scale is increasing. And thus, if all the factors are doubled and output is more than double, then returns to scale are said to be increasing. On the other hand, if increase in the factor leads to less than proportionate increase in output, this is known as the scale of production is decreasing. It is needless to say over here that this law operates in the long run. In short run, it is not possible when all the factor of production can become variable and can be changed in the same proportion simultaneously. It should be remembered that increasing returns to scale is not the same as increasing marginal returns. Increasing returns to scale applies to long run in which all the inputs can be changed, whether it is labor or it is capital, fixed or variable. Increasing marginal return refers to a short run in which at least one input is fixed and one input is variable. So, the existence of fixed input in the short run gives rise to increasing and later the diminishing marginal returns. I believe you understood. Before we move ahead, just write a short summary of what we have just understood. Just write meaning of law of returns to scale. Law of returns to scale. Change in scale means that All factors of production, all factors of production are increased or decreased, are increased or decreased in the same proportion, in the same proportion. The law of returns to scale analyzes the change in output, the change in output due to changes in scale in the long run, that is, quantities of resources, quantities of resources keeping proportion constant, keeping proportion as constant. Law of returns to scale, law of returns to scale. When there is an increase in scale, that is, increase in all factors of production, together in the same ratio, the marginal product will increase first, then it will become constant, and at last it will start decreasing. Start decreasing beyond a certain level. Stage 1, stage 2, stage 3. Let's see returns to scale now. As stated earlier, increasing returns to scale means that output will increase in a greater proportion than increase in input. When a firm expands, increasing return to scale are obtained in the beginning. For example, a wooden box of 3 feet cube contains 9 times greater wooden than wooden box of 1 feet cube. But the capacity of 3-foot cube box is 27 times greater than that of 1 feet cube. Many such examples are found in the real world. Another reason for increasing returns to scale is the indivisibility of factors. Some factors are available in large and lumpy units and can therefore be utilized with utmost efficiency at a large output only. If all the factors are perfectly divisible, increasing returns may not occur at all. So returns to scale may also increase because greater possibilities of specialization of land and machinery would happen. I hope you understood. Let's see constant returns to scale now. Constant returns to scale, this is stage 2. Constant returns to scale, this is stage 2. Increasing returns to scale, this is stage 1. Stage 1, stage 2. So as stated above, constant returns to scale means that with the increase in the sale of some proportion, output increases in the same proportion only. So constant returns to scale, otherwise called linear homogeneous production function. It is known as linear homogeneous production function and may be expressed as follows. If all the inputs are increased by a certain amount, say K, output increases in the same proportion of K. It means that it has been found over here that an individual firm passes through a long phase of constant returns to scale in its lifetime. Let's continue and see stage 3, that is decreasing returns to scale. Decreasing returns to scale when output increases in a smaller proportion in relation to all the inputs. Decreasing returns to scale are said to prevail when a firm goes on expanding by increasing all the inputs. Decreasing returns to scale is set. Decreasing returns to scale eventually occur because of increasing difficulties of management, coordination, and difficulties in controlling the organization. When the firm has expanded to a very large size, it is difficult to manage and with the same efficiency as before. Because a small firm is easy to manage, a large firm is not so easy to manage. A lot of difficulties will come. Cobb-Douglas production function explained earlier is used to explain the returns to scale in production. Originally, Cobb and Douglas assumed that returns to scale are constant. The function was constructed in such a way that components summed to a plus 1 equal to a minus 1. However, later they relaxed the requirement and rewrote the equation as follows. Q equal to K is capital L is labor, and over here A and B is the constants. A and B is the constants. Just see where Q is the output, L is the quantity of labor, C is the quantity of capital, K, A and B are the positive constants. I believe you understood. Let's continue and write an example. Write an example. Assume basic proportion of resources is one machine and 3 workers. That is 1M plus 3W. Here total product and marginal product are indicated in terms of quantity. And what is the quantity? Units. Just make this small table. Total product, marginal product, over here it is serial number, and just write scale or factor input used. So this is the scale, one machine and 3 workers. The total production is 2000 units. The marginal production is also 2000 units. This when you increase the machine, 2 machine and 6 worker, the proportion is same, my dear students. The total product rises to 5,000 units and marginal product is 3,000. 5,000 minus 2,000 is 3,000. When you use 3 machine and 9 workers, in that case the total product is 9,000 and the change is 4,000. That means 9,000 minus 4,000 minus 5,000 equals to 4,000. When you use one more machine and 12 workers, in that case the total product rises to 14,000 and over here the marginal product is 5,000. 14,000 minus 9,000 is 5,000. When you use 5 machine plus 15 workers, in that case it is 19,000. The total product is 19,000 and marginal product is 5,000, that is 19,000 minus 14,000. When you used one more additional unit, in that case 6 machine plus 18 workers, the combination is 1 machine and 3 workers, so the output, the total product is 24,000 and this is marginal product is 5,000, that means 24,000 minus 19,000. When you use one more machine, 7 machine plus 21 workers, that is 28,000, the total product is 28,000. Over here it would be 4,000. The marginal product is started declining. We reach to stage 3, 28,000 minus 24,000. Getting it? The next is when you used 8 machines and 24 workers, in that case the total product went up to 31,000, that is 3,000, that is 31,000 minus 28,000, the marginal product. And when you use one additional unit of machinery, 9 machines as well as 3 more workers, 27 workers, in that case the total product increased to 33,000 and the difference is 2,000. That means the marginal product is 2,000. 33,000 minus 31,000. I believe you understood this. So this is stage 1, this is stage 2 and this is stage 3. Increasing return, constant return, diminishing returns. I believe you understood. Just make this graph. X, origin, Y. Y-axis we are showing the product. This is stage 1, that is increasing return. Stage 1. Then constant return, stage 2. Stage 2. And there is a diminishing return, stage 3. Diminishing returns. We had just studied this. Decreasing returns to scale, constant returns to scale, and increasing returns to scale. You can write over here, stage 1, increasing returns to scale. Stage 2, constant returns to scale. And stage 3, diminishing returns to scale. Diminishing returns to scale. I believe it is okay with you. Understood it well? We are moving ahead now. The next point is Cobb and Douglas production function. We have done in short, but write some notes in relation to this. Cobb-Douglas production function exhibits returns to scale in production. Returns to scale in production. A plus B is greater than 1. That means what? This is increasing returns to scale. Output increased more than proportionate use of factor. Over here, output increased more than proportionate use of factor, and factors is labor and capital. More than proportionate to use of factors. Factors is labor and capital. Clear? Constant returns to scale. A plus B equals to 1. You can write constant returns to scale. What happens over here? Output increased in the same proportion. With all factors. A plus B, stage 3, is lower than 1. That means what? Decreasing returns to scale. Decreasing returns to scale. This means what? Output decreased more than proportionate to use of factors. Factors like labor and capital. Understood? Cobb-Douglas production function is shown in this manner over here. The next concept is production optimization. Production optimization. Normally, a profit maximizing firm is interested to know what combinations of factor of production, that is inputs, would minimize the cost of production for the given output. This can be known by combining the firm's production and cost function, namely isoquant and isocost lines respectively. Let's understand what is isoquant. So isoquant is similar to indifference curve, this is IC curve in the theory of consumer behavior. An isoquant represents all those combinations of inputs which are capable of producing the same level of outputs. Since the isoquant curves represent all those combination of inputs which yield the same or equal quantity of output, the producer is indifferent as to which combination he chooses. There could be combination 1, there could be combination 2, there could be combination 3, but all the combination, the output would be same. Therefore, isoquant is also called equal product curves, production indifference curve, or isoproduct curves. The synonyms we need to remember: equal product curves, isoquant curve, production indifference curve, or isoproduct curve. The concept of isoquant can be easily understood with the help of the following table. Just see it over here. These are factor combinations. In combination A, the factor X is 1 unit, the factor Y is 12. In combination B, the factor X is 1, the factor Y is 8. MRTS is 4. What is MRTS? It is marginal rate of technical substitution. Marginal rate of technical substitution. In combination 3, the factor x is 3, factor y 5, and MRTS is 3. In combination 3, factor x 4, factor y 3, and combination is 2. In combination E, factor x 5, factor y 2, and combination is 1. Let us plot in this curve and understand how we can do it graphically. Equal product curve or isoquant. X origin, y. On x axis we are plotting factor x. On y axis we will plot factor y. Factor x 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Factor y 2, 3, 5, 8, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So first is 12 and 1. This combination 12 and 1. Then another combination is 8 and 2. This is combination 2, 8 and 2. The third combination is 3 and 5. Over here this would be 5 and we have 3. The combination D is x4y3. x4y3. Let's see the last combination E, x5y2. y2 and x is 5. Join all the line, all the points, all the combinations. Just join it by free hand. This is Q, this is I, IQ. Isoquants have properties similar to indifference curve. We had just seen it. Isoquants are negatively sloped, convex to the origin due to diminishing marginal rate of technical substitution, that is MRTS, and are non-intersecting. They don't intersect each other. This is IQ1. Like that, we can also have IQ2 and IQ3. Which one is better? IQ3 is better, but we should understand that we also need to understand what is our budget. So according to our budget, higher the IQ, it is better, but we should also take into consideration our budget. Let's continue. However, there is one important difference between two, whereas in an indifference curve, it is not possible to quantify the level of satisfaction acquired by the consumer. The level of production acquired by the producer is easily identified. Thus, while isoquant 1 represent 100 units, isoquant 2 and 3 will represent the higher level of production, while the curve on the right represent the higher level of output and left lower level of output. Let us see ISO cost now, which is also known as equal cost line. ISO cost or equal cost line. ISO cost line is also a budget line or a budget constraint line. Shows the various alternative combinations of two factors which a firm can buy with given outlay. Suppose a firm has 1000 rupees to spend and there are two factors available, factor X and factor Y. If the price of factor X is 10 rupees and price of factor Y is 20 rupees, the firm can spend an outlay on X and Y in various ways. It can spend the entire amount on X and buy 100 units, 100 multiplied by 10 equal to 1000, and 0 units of Y. This could be a combination. It can also spend the entire outlay on Y and can buy 50 units. 50 units multiplied by 20 equal to 1000, and can buy 0 factor, 0 X factor. In between, it can have many combinations of X and combinations of Y. Whatever the combination of factors the firm chooses, the total cost of the firm remains the same. In other words, all the points on the budget line could cost the same amount. Let us see an example, a graphical presentation of ISO cost lines. This is X origin, this is Y, and this is on Y axis we are showing factor Y, on X axis we are showing factor X. This is one combination, this is another combination, this is ENF, another combinations. Now read it and understand it. We can show the ISO cost line diagrammatically also. On X-axis, the units of factor X, and Y-axis, the unit of factor Y we have shown. When entire 1000 is spent on factor X, we get OB of factor Y, and when entire unit is spent on Y, we get OA. So on Y, we get OA, and on X, we get OB. I believe you understood. The straight line AB which joins point A and B will pass through all the combinations of factor X and Y. So there could be a combination over here, 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 here. Any combinations could happen. Okay. This is called ISO cost line or budget line. This figure shows various ISO cost lines representing different combinations of factors with different output or different outlays. ISO quant, which represent the technical conditions of production for a product, or ISO cost lines, which represent various level of cost or outlay given the prices of two factor over here, the factor X and factor Y. Factor X and Y, X is priced at 10 and Y is priced at 20, can help the firm to optimize the production. It may try to minimize the cost, obviously, for producing a given level of output. It may try to maximize the output for a given level of outplay. Suppose the firm has already decided about the level of output to be produced. Then the question is, with which factor combination of the firm should try to produce the pre-decided level of output. The firm will try to use the least cost combination of factors. The least cost combination of factors could be found by imposing the ISO quant that represent the pre-decided level of ISO cost line or budget line. I believe you understood. Least cost combinations of factors, that is producer's equilibrium. Just see this diagram, see this graph. X origin, Y. On X axis we are showing factor X. On Y axis we are showing factor Y. This is combination L, L1. Then we have M, M1. Combination N, N1, and Q, Q1. I hope you understood till here. SNT. This could be a tangent line. Here it is combination A, B, C, D, and E. This is P. Least cost combination of production in case of producer equilibrium. Least cost combination of factors, that is producer equilibrium. Over here, if you could see, just suppose the firm has decided to produce 1000 units represented by isoquant P. This is isoquant named as P. So these units can be produced by any factor combination lying on P, such as combination A, combination B, combination C, combination D, or combination E. All the combinations are possible because all the combinations are there on isoquant P. But the cost of producing 1000 unit would be minimum at the factor combination C. Why it is minimum? Because as you can see, whereas the isoquant cost line M1 tangent to the given isoquant, that is P, it is tangent, that means it is touching to P. At all the other points like A, B, D, E, the cost is more as compared to the points lie on higher isoquant lines compared to MM1. Isoquant MM1. Thus, the factor combinations represented by point C is the optimum combination for the producer. This represents the least cost producing 1000 unit of output. So if you are producing point C on isoquant curve, in that case, that would give you a least cost, and the profit will be in maximum, the producer will be in maximum benefit. That represent what? It represent the least cost producing of 1000 unit of output, and as well as we are clear that the tangency point of the given isoquant with the iso cost curve represent the least cost combination of factors of producing a given output. I hope you are clear till here. Okay, let's move ahead now. Let's see the next topic, and that talks about internal economies and diseconomies of scale. Just write along with me: internal economies and diseconomies of scale. Over here, economies means benefits of large scale production, and limitations, diseconomies means limitations of large scale production. Understood? Limitations of large scale production. So what kind of economies and diseconomies we need to see? Technical economies and diseconomies. Technical economies and diseconomies. We also have managerial economies and diseconomies. Managerial economies and diseconomies. Economies. Commercial economies and diseconomies. Commercial economies and diseconomies. Financial economies and diseconomies. risk bearing economies and diseconomies. The benefits of taking risk and the limitations of taking risk. Okay, if you are done this, let's continue and write external economies, external economies and diseconomies of scale. External economies and diseconomies of scale. The first external economies and diseconomies of scale could be cheaper raw material and capital equipment. Next could be technological benefits. So basically, there is a scope of discovery of new technological knowledge that could be used to improve the better machinery as per the new techniques of production that we can start. So in technical economies, we can say that this will change the technical coefficient of production and will enhance the productivity of the firms in the industry and reduce the cost of production. So it will act as an additional or external benefits or economies. The next is development of skilled labor, development of skilled labor force. So basically workers become well accustomed to do this, the various the various processes, and they learn from the experience that they get from expansion of industry. A lot of trained and skilled laborers are developed in the industry, and this will get a favorable effect to the company or the firm. The next is growth of ancillary industries, growth of ancillary industries, growth of ancillary industries. Basically, ancillary industries means what? As the industry expand, the number of additional small ancillary industries who specializes in the production of raw material, small tools or machinery, they can be able to provide them at a lower prices to the main industry. So when a main industry is emerged somewhere, a small supporting ancillary industries automatically come into picture. What is the benefit of these industries? So they process the waste product of the industry and make some useful products out of it. So the basically you can say that the recycling process also happens over here in ancillary industries. What are the benefits? You can say that better transportation, better transportation and marketing facilities and marketing facilities. Okay, better transportation and marketing facilities. We can say that transportation and marketing network develops to a greater extent, and because of this that can reduce the cost of production for the firms. The communication channels or communication system, the innovative communication systems may get modernized that will result in quick and effective flow of information. So this will definitely help the industry. Students, we had seen external economies. Over here we had seen external economies, and now just see external diseconomies. External diseconomies. External diseconomies may cease if there are certain disadvantages which may neutralize the advantages. Of the expansion of an industry. These factors are called external diseconomies. External diseconomies. The first factor is rise in factor prices. Rise in factor prices. Rise in factor prices. That means what? You can write when an industry expands, the requirement of various factors of production increases. This may result in pushing up the prices of such factor of production, especially when they are short in supply. When they are short in supply. Okay? So first point we had seen rise in factor prices. This will act as a diseconomies of scale. Another point is higher cost of production. Too many firms in an industry at one place may also result in higher transportation cost, higher marketing cost, and high pollution control cost. High pollution control cost. If the cost will be higher, the profit will automatically will be low. The third diseconomy is government will put a lot of restrictions. The government may prohibit or restrict expansion of an industry at a particular place because of several reasons by way of its policies. The policies could be, let's not improve the pollution level in this place. We don't have the more place over here. The city is congested, so let us not allow the industries to develop over here. Go in some remote areas. So government can think and make policies like that. Students, we have completed this unit, that is chapter 3 unit 1, and in today's class it was lecture number 6. What we have dealt, just take a quick recap. We have seen the returns to scale. There were returns to scale, 3 stages: in increasing returns to scale, then we had seen constant returns to scale, and then we'll move to decreasing returns to scale. We had seen this, we have understood this by an example which is there on your screen right now. We have done this graphical presentation and returns to scale. We have seen Cobb-Douglas production function in detail, and then at last we moved to the production optimization part. We have seen the two concepts, that is isoquants and isocost. This is isoquant, equal product curve or isoquant curve, the IQ curve, and then we have seen isocost, which is also known as equal cost line, budget line, isocost lines. Now the best combination could be the iso cost line should be there, but we also need to see the company's budget. So if we are able to afford that, it's great. If we are not able to afford it, in that case, in the above example in figure 4, the combination C is the optimum combination because A, B, C, D and E are not well. So isoquant P, and the best combination is C. Then we have seen the internal economies of scale, internal diseconomies of scale, external economies of scale, and external diseconomies of scale. So here I end this class. We have completed unit 1 over here in chapter number 3, and from here we'll continue with the next unit, that is unit 2 in chapter 3. Thank you. Thank you all.